know that our SDLC processors are basically a house of cards.
Exactly. Yeah.
Hey everyone, welcome back to another episode of the DevOps Roundup podcast. Today we're going to be taking a deep dive into the theory of constraint. Make sure you hit that subscribe button, drop a like, and let's get into it. Hey Sean, what
Hey,
do we know about the theory of constraint?
Oh yeah, I brought this up to figure we can start talking about this, kind of getting into more in depth in the theories behind DevOps and value stream mapping and the likes of that. Um, the theory of constraints. I can go ahead and show. You have the book still handy there?
Yeah, I got one right here. The goal, where it's got it right here. The theory of constraint.
Yeah. Dr. Goldratt, right?
That's what it says on the cover here. Yep.
Yeah.
Eliyahu Goldratt
Oh, I won't even try to pronounce his first name.
with Jeff Cox.
Yeah. So this was a book that came out in the I believe the late 60s, and it pretty much lays down the theory that any system.
84.
84?
That's first edition. Is 84.
Okay. So some of his works date further back, but 84 is still,
relevant enough.
Yeah, relevant enough. Yeah. But he wasn't necessarily writing directly about software, but software is a system. So it works with software development and the SDLC. But basically, it states that any system is only as strong as the weakest link. So if you envision a chain, and how much can that chain pull or produce? It can only produce as much as the weakest link in that chain can do. So if you're trying to improve a system, you want to look for those weak links and improve those first. And it further goes to say, if you're just looking to improve processes that can be improved, you can hurt the system by improving the wrong process.
So this is making sense than why I have this book.
That I have not yet. Are you going to explain that you have all these books that I'm referencing, but you haven't read them?
Well, I haven't. But so this is part of my master's coursework. So this was a required book for one of my courses, but the course was on lean, just lean. And so value stream mapping and what you're describing
is coming back to you now.
Yeah.
So those books apparently weren't mandatory reading, but they're mandatory purchasing, right?
Yeah. And given that the Boeing company paid my $50,000 master's, I happily got every book. I
bought all the books that
every book, all the optional ones too.
So it's definitely worth a read. It very much spells out in a different storytelling manner than Gene Kim's The Phoenix Project, but ultimately they have the same underlying points that you want to look at a system, and in our case it's usually a software development system, the software development life cycle or DevOps, which the SDLC fits underneath. And you want to follow the entire path from requirements to producing whatever you're producing, so your deliverables at the end, and find out where the constraint is. There always will be a constraint,
right?
And if you want to improve the entire system, you want to improve the correct constraints, and not just the ones that are easy to improve.
Correct.
Because you might make the whole system just collapse if you
we already know that our SDLC processors are basically a house of cards.
Exactly. Yeah, they are definitely a house of cards, depending on especially depending on some of the software tools that are used to support it. Some are better than others, but none of them are perfect. And if you start improving, the CI portion without improving the deliverable or your operation, well, then you end up burying operations. They just can't keep up with the churn, and then the whole system just crumbles.
Yeah, and just in case you've never heard of a constraint, right? So you can think of a constraint as the bottleneck. Mm-hmm. There's a part where a lot of work has to basically come not to a halt, but maybe drastically slow down so that it can get through that narrow little part of the system that isn't at the same throughput as the rest of your processes and stuff like that. So we identified the constraint. That is step number 1.
Yeah, find it. Yeah.
Next one, we want to exploit it. Get maximum output from the constraint with existing resources. Any thoughts on that? How do you read that?
Yeah, well, it's different for every scenario. You basically have to really, you have to identify. We've already identified the constraint, but you have to describe it. You have to understand the constraint. So it's not enough to just know that this group is causing the problem, but why are they causing the problem? What's the reason behind it? What's the
Yeah, when I was a systems engineer, which is also why I took these courses, because it was part of my systems engineering coursework. One of the things that one of my managers taught me was the 5 whys. Like, when you do find a constraint, you should ask yourself at least 5 levels of why. Why is this happening? And then why does that happen? Yeah. And I think Elon probably puts his best. And I hate that we turn this podcast into the Elon show. But Elon puts it best with also known as first principles, right? Like, what are the laws? What are the governing laws that dictate what is actually can or can't happen? Because if you have anything that's not a first principle, then it's just some excuse or some arbitrary thing, the rule that somebody made up.
Yeah, we this is the way we've always done it, is what I hear a lot. Like, why do we have to have, this particular meeting before we can move forward? Oh, that's just the way we've always done it.
Right.
Okay, why have we always done it that way? And often there's no answer to that. And like, okay, so if we don't know why we've always done it, let's stop doing it and see what happens. Or you get a little bit more detailed than that, and try to flush out, okay, what would the repercussions of not having this meeting be?
Yeah, but you got to pull back a little bit more, right? It's not enough to just ask that first why we have a meeting.
Yeah.
Well, why?
Yeah.
That's level 2.
Yeah, if the answer is we've always had the meeting, well, why have we always had the meeting?
Right. And oftentimes either it was because somebody had an idea and we just never challenged status quo, or my favorite is there was some sort of an ethic thing that we now try to prevent, right? We build processes around safeguards. We build safeguards to get ourselves not into legal problems or trouble.
Well, or there was a failure at one time, and so we put up guardrails to avoid that failure, not realizing the guardrails really create a bottleneck. And that one scenario that caused the failure, it was a 1 in a million chance.
But you gotta be you gotta be careful with these things, though, right? Because regulated industries typically are slow because of all these constraints that have been evolved into the process. But you also want to be very careful, right? Because like SpaceX is we're turning this into the Elon show again. But SpaceX is a great example.
You need to find another hero.
I know, right? I do. Well, have you read Elon's book, the one by Walter Isaacson? There's one that I actually read.
So is it really his book? Somebody else wrote it?
Well, yeah, because he spent then like a year and a half with them, writing it and documenting it as he was, living his life. But when he was doing SpaceX, SpaceX is space travel. NASA is a heavily regulated industry, right? And look at space launch systems.
Or it was,
yeah. But then like Elon, when they came in with SpaceX, they're like, well, why is there this rule? And Elon's like the master of like why. Like, I don't know if you heard recently, but like, there was this thing where he couldn't get the permit to launch the rockets because there was like water that was contaminating, but then they needed the water to cool the rocket down. but then they were getting fined because the rocket was not being cooled down and it was contaminating. But then they needed the water, right? Like there was like this infinite loop that Elon's like, make it make sense.
Yeah. No, I had not heard about that, but
Yeah, well, there's a lot of rules.
follow
Yeah,
Elon.
there's a lot of those examples, but one that I wanted to pull up is, again, with the cautionary, right? Because it's easy to identify the bottlenecks. I think it's easy, right? I think most people.
That's the easy part of the problem,
Yeah,
is identifying it. Yeah.
But should you, or how you go about fixing the bottleneck, I think that's where there's it's an art, right? And so the reason I was going down the Elon rabbit hole is because when they were building the roof tiles, right? When they were doing the Solar City, what is this electric company? Whatever it was before it merged with Tesla, they were like, they need 3 nails. And he's like, well, do it with 1 and see what happens. And all the shingles start flying off. It's like, okay, try 2.
Try 2. 2.5.
Yeah. But it's that concept of like, people just do it because you do it because it's the way it's been done. But like you like try. Sometimes you tip too much. And so it's like a middle ground that you got to figure out. Sometimes that's the art.
Well, sometimes once you identify a constraint, the short-term fix is creating another constraint upstream. So by the time the workflow gets to the existing constraint, it's not as much of a bottleneck, and the workflows right through.
So step 3 is subordinate everything else. Align all the processes to support the constraint, so that you don't kick the can.
Yeah.
Because the last thing you want to do is if you're kicking the can, then that's not a good thing either. Like it's just going to be tomorrow's problem.
Sometimes I like to describe it as a garden hose with many kinks in it. So if you're trying to fix a garden hose to make the water come out the end, which kink do you unkink first?
I don't know, the one closest to you. I like to start at the edge.
the one closest to the output, and then you work your way back. Because if you unkink the very first one, you're still not going to get water out. You're just putting all the pressure on the next kink.
We're gonna have to go into video mode here because I want to show you something that I've done in the past. But keep talking while I get it ready. Well, because I think this is an important point, right? Like I think a lot of people jump, especially like the newer generation. I mean, I want to tread carefully here.
They jump to the low hanging fruit, and you can't necessarily do that with a system. It feels good to jump in and fix something that's easily fixed and be the hero for the day. But then ultimately it could knock your house of cards down. So you really do need to be careful of what you do with an existing system. And a lot of this is for existing systems. When you're starting up a brand new system, you obviously are trying to build it without constraints.
And I think a good example of this has been data center versus cloud. My wife and I were talking about this the other day. We're like, why did Atlassian do the Great Fork? Like, why did they divert so much when it came to, like, they already had a Jira? Why did they rebuild a brand new Jira? And my theory is that, well, there was just so many, like, it was band-aided and duct taped together.
Yeah. And it didn't take any advantage of cloud native technologies.
And so to do any refactoring there, any improvement would mean you literally, you're kicking the feet under the house, and you're dropping the house of cards. So it's easier to just start all over with a fresh new model.
Yeah. No, I think you're not only is your theory spot on. I have heard Atlassians give a presentation that exactly explains that.
Oh, you should probably watch that one. So I wanted to walk you through here. So maybe do a little bit of a demo or an exercise, because I've done something very similar to what we've been describing with this identifying your theory, identifying your constraints. And this was an exercise that I was taught, again, when I was as a systems engineer, and figuring out, like, why do things not work, right? And so I wanted to maybe start off with something simple, right? Something relevant to us. And that is, we want to get to 1,000 subscribers, right? This is the output of this channel, right? like monetize the channel. And this is an exercise that I usually like to do because I start at the end, right? I know the output. I know what I want to get out of my system.
Okay.
And so I work backwards from there, right? And so what are the two things that we need to do, right? We need 4,000 subscribers, right? Sorry, we need 1,000 subscribers.
It's actually 500 now.
No, well, it depends on the monetization policy we want, right?
Oh, okay.
But we need 1,000 subscribers and 4,000 hours.
Okay.
Right. That's if you want the full tier, all the monetization.
Okay.
And that's a great example, right? Of like, well, we can unlock channel membership at 500 subs.
Oh yeah, it's the memberships.
Yeah. Right. And so this is where, again, AdSense is what we want, right? Not necessarily memberships, right? So you can fine tune your output. But then from here, you're like, okay, so how do we get to 1,000 subscribers? Right. And so that's where you're like, well, you can, LinkedIn posts.
Yeah. Bribes.
Right. Yeah. You can bribe your people. Yeah. So this is where you start working backwards to essentially build out your process. Right. And one of the exercises that I always used to do at work would be like, okay, this LinkedIn post, why can't we do this one? And somebody's like, oh, well, only one person can post to the account or something. And so that's where you like start troubleshooting. Okay, so why do we have
why is there only one? And yeah.
And so but until you know your process, right? And this was the first exercise that I did when I joined this new team, which was on day one, we're like, okay, today, if you didn't change a single thing, how do we get from A through Z? Just call it all out. Doesn't matter where the efficiencies are. It doesn't matter where the constraints are. We just want to know, because oftentimes, going back to identifying that constraint, which we said is easy, but in technicality, it's not easy if you don't even know what you do.
True. Yeah. Yeah. To refine what we said, it's probably the easier part of the system, but it doesn't, or the process, but it's not easy.
Yeah. Because you need to know how your process works.
Yeah. You need to identify your process, which goes to, what they've defined as value stream mapping. And that's basically just sitting down in a room with all the key people and figuring out what happens in your system. What are all the moving parts?
Yeah.
And often than not, you'll find out that you didn't understand half the system.
It's just people are like, I know that I do this part. And the fun part is connecting them together, right? Like, we know Timmy in accounting does their part, and he's like, I just received this. And the real question is like, well, how does anything get over to Timmy? Should something have to go to Timmy? Why do things go to Timmy?
Yeah.
And
I had a customer who I won't name years ago that had a major constraint in their system and their software development that nobody knew except for that one guy. And until we sat down and did what eventually became value stream mapping, nobody knew that this one guy was holding up the whole process. And it turned out that he would spend more time explaining why he can't do something versus actually doing it. And once we identified that and retrained him a little bit, the process started flowing much
better. Have you ever heard of the
release team, DevOps tool specialists? We provide professional services and software reselling around the leading software DevOps tools like Atlassian, GitLab, GitHub, JFrog, and others. To talk with us about DevOps, here's our contact information. Please call 866-887-0489 or via email at info@releaseteam.com.
Better. Have you ever heard of the Mythical Man Month?
Yes.
I think this is appropriate in the conversation too, right? Because the Mythical Man Month, basically, it's a mathematical equation apparently, where it's this concept where if you add more people to a problem, then you'll get to the solution faster.
Yeah, that doesn't happen.
But it's the opposite is true, right? So their mathematics here is if you have 50 developers, right, then you just open up, like if you have 50 and you have 50 more, you just open up 1,200 different channels of 1,200 new opportunities for failure.
Yes, yeah. So interesting that you brought this up. I was having a conversation with an investment company earlier this week, and the big question they wanted to have answered was, how soon will AI allow us to cut software developer headcount? And my answer is probably never. You may get to a point where 5-6 years down the road that corporations don't have to have a whole software IT team anymore, but near term it's not. So with the mythical man month, throw the AI equation in there as well, is so now you're multiplying that number of points of failure by what?
A million?
by a million. I was saying like by a tenfold or something. Because now you have all these people also using AI, and AI giving you slightly different answers depending on how you prompt it.
Yeah, and also the hallucinations, right? And so I think as an assistant and as a helper guider, just to kind of get the creative juices flowing, it's phenomenal. But to entrust the system to build the system, that's challenging.
It is. I still hesitate. So I got a good Rovo story for you.
Yeah, let's hear it.
So I asked my employees to come up with this report. And they put it in a table in Confluence, mainly because I prefer to have all my information in Confluence. But it really needed to be in a spreadsheet. And because the questions I'm going to be asking is, I need sums based on vendor names and sliced by time. And super easy to do if this information was in a database, or not a database, an Excel spreadsheet versus a table or even a database inside a Confluence. However, we have Rovo. So I just opened up the Rovo chat and I say, sum up this table based on vendor name and dates. For this date range, I want to know how much we sold per this app vendor, and display it to me in another table. And every time I ran it, I get different numbers. It's like, come on, Rovo, can't you count? It's like, I'm not did give me a disclaimer that this is a very large table, and that we only used visible rows. So I'm like, well, only the rows visible to me or visible to the page. I don't quite understand. And yeah, it was thousands of rows in this table, but for a spreadsheet, that's not that many.
Something VLOOKUP can do for you very easily.
Exactly. Like I could have done this with a command line script, doing grep and something, and summing it up. Rovo was giving me different answers. So I knew one specific answer was, vendor A was at $250,000 for Q1 of this calendar year. And I never got that answer. I got 80, I got 150, I got, it never went over. So I guess by Price is Right rules, Rovo did a very good job. But yeah, it was like, oh, this is ridiculous. And I played with it longer than it would have taken me to download this to Excel and just, put in the formulas.
Google the formulas too.
Yeah.
If you probably would have gotten a better result had you said, help me build this in Excel. Like, help me, like, here's a file, analyze it for me as an Excel file.
I should have tried that. I didn't think of adding that to my prompt. Basically,
yeah, no, well, like if you feed the file to like Claude or Jibbity,
okay,
right?
Yeah,
it probably could have analyzed it better for you than had Rovo done it.
Yeah, because it was just a table on a Confluence page, and I was just saying, summarize this entire table. So I had to add entire table because initially it wasn't doing that. It was only doing like 4 or 5 rows, and then saying, yeah, I'm done. It's like, I don't think you understand the term summarize, Rovo.
But eventually, I think AI will get to the point, like at least staying on the topic of Rovo and then merging with our theory of constraint, right? One of the benefits that Atlassian has been yelling from the top of the mountain here has been Rovo is going to have that contextual information because it has connectors that connect to your email, to your PowerPoint, to your Excel, right? And theoretically, I can envision a future, at least this is the one that Atlassian sells to us, that you go, hey, Rovo, find me my constraints.
Yeah.
And it, in theory, is, I mean, it's being engineered to help you with just that.
I think eventually it might be able to do that if you're using all the tools that can connect to.
Business is a complicated beast, though. I don't know.
But yeah, there's a lot of offline or manual steps in any process that you really want to work to get rid of. But
I mean,
ultimately, something needs a person to approve something.
yeah, because like, how do you identify quarrels between coworkers?
Yeah.
Right, because those can be constraints, right? Like if somebody is like intentionally withholding information because they're just mad at their manager, or they know that if
don't like working with this other person, so
yeah, or just job security, right? Like a lot of people intentionally make processes complex and hard because it's harder to fire them.
Yeah,
they're the only ones that know how to do it.
I have seen that a lot.
And so, like in the age of AI, I don't know how it. I don't know. In the age of just tools in general, I have them for Ape Tech for my main channel. I have member only videos, because of that membership thing. And so today I did a video about like before you go and get mad at Jira for not working well, check your processes first.
Yeah.
Check your people problems first before you go try to, yell at Jira or maybe you're on Monday and you're
I completely agree with that. And very often I say something kind of the reverse of that is before you ask me to implement something in Jira, can we just do this in training? Isn't this just, hey, don't do that? It goes back to you go to the doctor, you say your arm hurts when you move it this way. And the doctor says, don't move it that way.
You remember the antenna gate from Apple?
No, I'm not sure I do. The antenna gate?
Yeah. So back in the old iPhone 4 days, Apple switched. You probably never had an iPhone, have you?
I've had a iPhone once, but not for phone related purposes.
So it's hard to see because of my screen so dark. But you see that little slit right there?
Okay. Right there? Yeah. That's the antenna.
That's the antenna band. So there's one on the top and there's like one on the bottom.
Okay.
And they're just around the phone, right? You see the 4. Well, their placement of it in the iPhone 4, I believe, was right here where your pinky would rest.
Oh, so you'd be
and so within your palm and then within your other phone, you basically cut off the antenna. So you couldn't make any phone calls. You couldn't receive any. If you're on the middle of a call and you went like this, then you just killed the call. and so you were just like basically sabotaging your phone every time you were just holding it.
Yeah.
Right. And
no, I never ran into that or heard of that before.
Yeah, well, Steve Jobs. Well, here's the controversial topic, right? So Steve Jobs was asked, "Hey, what do you guys plan on doing to fix this?" And Steve Jobs was like, "This is the infamous, is what it is. Just don't hold your phone that way."
Yeah. Cut off your pinky. Yeah.
Ultimately, Apple gave everybody bumpers that just literally went around the edge, so that it was the skin to the metal contact that was killing it.
Okay. Yeah.
And so they're like, well, if you don't make the skin to skin, like then you're fine. So, but it was one of those. It was one of the most infamous lines. You should look it up. Where Steve Jobs was just like, just don't do it that way. I'm not gonna re-engineer my phone because you don't know how to hold.
The phones are already out there. We're already selling them. We're not just. There's better.
That goes back to again that mentality though. Back in the theory of constraints, like those are valid answers that people will be giving you. Like, what's the bottleneck? But you put up with it. You deal with it.
Yeah. It's always been that way. Yeah.
Yeah. Have I ever told you the monkey experiment? I probably should. I'm pretty sure I did.
Oh, what's your monkey experiment? I'll tell you what mine.
I'm pretty sure the last time I asked you if I told you the monkey experiment, you asked me, "What's your monkey experiment?" Deja vu. The monkey experiment, about 3 monkeys. They get fed and then they get shocked every time they eat, so they don't take the food.
Okay.
So then
this is very similar to mine.
So then they swap out a monkey. Elaborate. Yeah, they swap out a monkey, and then that monkey sees food. He goes and grabs the food. The other 2 jump in and go, "No, don't do that," because the other 2 have been shocked, and this one hasn't. Eventually, they cycle through all the monkeys where none of them have been shocked, but none of them get the food.
Yeah,
but they don't know why they don't get the food, and that's because the first 3 used to get shocked. And so
that's mine's the same story, just a little more elaborate with a ladder, a banana, and a fire hose. But the same thing. Yeah.
But it's to conclude the episode, right? To conclude today's topic on the theory of constraints, be on the lookout, right? If you're frustrated with how your throughput, right? If you feel like your team's working 1,000 miles per hour, but you're just not moving the needle, or you just something just doesn't feel right. Because with these like theory of constraints, right? Like these bottlenecks are usually you feel a bottleneck more than you can see a bottleneck.
Yeah.
And so go and evaluate your process. Do a little bit of that mapping exercise. Look up value stream mapping, but eventually you do need to know in order to fix the problem. What is it? There's a famous quote, right? In order to solve a problem, you first need to. What is it? There's something about like in order to yeah, right. In order to make change, you need to recognize you have a problem first.
Exactly. Yeah.
And so you won't be able to do that unless you first recognize your problem. So you got to know your process end to end, because any assumptions in the process is a bottleneck in itself.
Yeah, and if you're walking into a new job, a new site, and you ask about the process, most likely it's not documented. If it is documented, don't trust it. Someone put it together in a PowerPoint and never updated it. So you can use it as a guide to find out what the true process is, but don't trust it.
Ever tell you about our missing wires on a plane?
No, we shouldn't have missing wires on a plane.
We shouldn't. But when I was in college for my undergrad, we'll finish with this anecdote here. Sure. Our professor, we had to do it was a hardware engineer, right? So we had to connect circuits together. And so our instructor showed us how to line trace with crayons.
Yeah.
And so we would trace the wires with different colors. Yep. Just so that you could, that you confirm, because when you're looking at a diagram of a
schematic, it's all black and white. You can't, there's thousands of wires on that page.
Right.
It's ridiculous. Yeah.
So here we are. Our plane's not working correctly, and we have this, plotter paper, butcher paper, huge drawing of the entire aircraft systems, and all the lines are on there, right? Yeah. And everybody's like, everybody with their fingers kind of following it. So what I did was like, I went and grabbed my crayons and I started line tracing and go, here's all the lines, guys. And then they're like, where's the two that were missing? The diagram was wrong.
Oh, okay.
So somebody didn't rev the diagram.
Yeah.
They were on the plane, but they weren't on the diagram. Yeah.
Yeah,
and so
very similar. So when I was in the military, just to add to the story here a little bit, I repaired radar systems, and they're very complex, and they had ridiculous wiring in them. And we did the same thing. We had these, these gigantic encyclopedia thick schematics, and the schematics were like 3 feet by 2 feet wide. Real pain in the ass to carry around, especially if you're out in the middle of the forest trying to fix a radar system. But we, during the classes, we all had these, colored pencils, and we made sure at least all the power, power and ground were colored in. So it was easier to trace when you actually were working on the system.
Sometimes you got to help out, because things can get cross-eyed. So anyways, folks, don't give up on your processes and try the theory of constraints. I think it's a very good idea. It's definitely good. And I was going to echo on if you're a new person, you're in the best position to play that innocence card and go, how does this work?
Yeah. Why?
Why does this work? Just don't fall victim of have you ever seen that meme of my code doesn't work and I don't know why, my code works and I don't know why?
Maybe.
Yeah, there's a pretty famous, well-known meme of let me see if I can find it.
But yeah, well, Alex is looking for that. A good time to stock up on colored pencils and crayons.
My code doesn't work. I have no idea why. My code works. I have no idea why.
Idea why? Okay, yes, I have seen that.
Yeah, because
you just didn't ring a bell when you mentioned it.
Right. So challenge status quo. See if we can improve things, and good luck.
That's how you learn. Yeah.
And if you made it this far and you haven't hit the subscribe button, now's your chance to hit the subscribe button. Drop a like as well. Shout out to Release Team.
Sure. Shout out to my company, Release Team.
Shout out to Release Team. If you need help with
until next time, I'm Sean Doyle, my co-host Alex Ortiz, and we'll see you on the next episode.
Bye.